So once again, good morning, ladies and gentlemen. The main topic of today's lecture is, can the computer be wrong? Can the computer err? It's really very important questions because we are using computers on everyday basis. Sometimes it's something, well, let's say stupid as playing some kind of a games, but thinking about playing games can be way of work for living, so it's not so stupid. But computers are used in banks, computers are used in hospitals. It's a very important problem. Are used on everyday basis in engineering tasks like construction, developing big constructions, bridges, buildings, and such things. There's a content of the lecture showing you some sources of errors. The first one is data. The second one is human, the operator, computer operator. Some errors came from the hardware, and I divided this into two classes: inevitable and this which we can avoid. Sometimes some manufacturer faults. And the last, but the most important source of errors is software. Short information about so-called bug-free software and some examples of software bugs. Data. One of my lectures was talking about errors in data, especially during data measurement. We make some kind of an error. Measuring some quantity, we cannot got it exactly. Well, after my previous lecture, I have left some device. Oh, sorry. What a mess. What we have to measure is this. Using this as a unit, we can observe that the length of the line is a little bit longer. This it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is longer than 10, but shorter than 11. And this is called an absolute error. Of course, changing the unit length, we can easily solve the problem, but in each case, we got to the end of the scale. So the perfect situation is when we know about this error and can use it during computation. But very often we are taking the data, some measurements like a temperature measurement, which never will be perfect, length measurement or any other, some physical constants. For example, a gravitational constant, which changes from place to place, but we are all treating this as 9.85 or something like this. So knowing the range of the values, we can predict the result and ranges of result, absolute error of the result, but mostly we are using all the data, not caring much about measurement errors. And we do believe in computer calculations. Not very important, but at every point, preparing the data for computation, we should think about this operator. Well, humans are only humans, and it's quite difficult to take into account all human errors. Sometimes operator does not understand the problem solved by the computer, by the application. Got some questions, some prompts, and gives back wrong answers and believes in results. Make error in preparing computer data. It's quite a lot of human-generated errors, but you know, it's not predictable. And when you are using some application, the programmer, what programmer can do with this? Nothing, probably, if you will use it in proper way. So, well, this is the source of errors, but it's unavoidable hardware. I was also talking about this. Most of today computers have 32 or 64-bit processors. What does it mean? And this means that we have only 32 or 64 places for storing individual bits. And the largest value which can be stored on 32 bits is 2 in power of 32. And bigger values doesn't fit, especially when we are using 2's complement notation, and all computers do use it, and think about 8-bit processor. Well, so we have 1, 2, 3, 4, 5, 6, 7. Wow. Okay. This bit is reserved for a sign. And these bits, 7 only, are used for data. The biggest value, biggest positive value is 0 in here and 7 ones. What will happen if we increase this value by 1? Let's clear the table, and once again 0, 1, 2, 3, 4, 5, 6, 7, and I'm adding here 1. 1 plus 1 in binary arithmetics is 0, 1 here, 0, 1 here, and so on. So the result is unexpectedly negative, because this bit, sign bit, is equal to 1. This value is 127 plus 1 gives us minus Well, it's another problem. How big is these values? But I can tell you it's minus 128. This is kind of a hardware error, but we made this error by design. We decided to use 8-bit arithmetics. The same with 32-bit arithmetics, but the range is much higher. And this is exactly the same problem with 64-bit arithmetics, but the range is even higher. When we know about this, we can, well, avoid these errors. This is not exactly an error. It's simply our design decision to make computer working only using 32 or 64 bits. Exactly the same with floating point numbers used in engineering computations. Also, we have finite range. When we are using 32 bits, the smallest, not equal to 0, positive value is as low as this, but each value smaller than that will be exactly equal to 0. The highest value used by 32 arithmetics is as big as this, not enough for most modern engineering computation, but still, every value greater than this will give us infinity. Well, switching to 64 bits computers, the range increases, but still every value positive smaller than this value is equal to 0. Every value bigger this one is enough. Once again, infinity. Yeah, we can switch to 128 or 256-bit computation. Not quite easy, but we can do this. But always, in each case, the range will be finite. There's also another problem connected with such with this floating point arithmetics is amount of significant binary digits. When we are using 32-bit computer, we have only 7.2 decimal digit. I was talking, this was the lecture number 5. 7.2 decimal digit means that it's a mostly 7, sometimes 8, in average 7.2. Well, increasing number of bits used for computation, we got 53 significant binary digits, which means 15.9 decimal digit, mostly 16, sometimes 15. This gives in average 15.9. If you remember the first lecture when I was talking about the entropy and meaning of information, each decimal digit, requires base 2 logarithm of 10, which is about 3 point something bits. And when you divide this 24 by 3 point something, we'll got 7.2 decimal digits. The same in this case. Yeah, we know this. All of us engineers are using 64 bits for engineering computation, sometimes trying to use 128 bits, which it's not easy because there is no good and implemented by every microprocessor producer standard. But we have to remember that computations are inaccurate. Have to take this into account every time when we start the computation. There's the other problem connected with, well, for example, such a value as 1/10, which means 10 cents on 10 groszy. In decimal notation, it's finite value, 0.1 in decimal. But converting this to binary, we will got value which looks like this. Well, this group of bits 0011, as you can see, repeats so when we take into account only 24 significant bits, we will got something which is not exact 10 cents. It's a little bit higher. Another problem is that each value on, well, numerical axis, after converting into binary with finite precision, one value will be, well, this is another way. All these values will have one binary representation. These values which are close each to other are indistinguishable by computer arithmetic. Well, the main example is when you try to when you are using decimal arithmetic with only 3 significant digits, 2.71 is a perfect value having only 3 significant digits, and we would like to add to this value such number also 2 significant digits, but the value is much smaller. There is the result from arithmetic point of view looks like this. But after rounding to 3 significant digits, we got the same value. So big value plus small value gives us only the big one. And it's not important how many small values we will add to this big one, because operations are always performed on 2 arguments, and arguments are evaluated from left to right. So this gives us a this gives us A and so on. But when we change the order, when the small a's is quite a lot, these values are in the same range. So the result will be 2a, this will be 3a, and so on. When we have 1,000 values, we will have 1,000 a's plus a big A, and the result is when these values are in the same range, the result will be quite different, definitely different than A. So it's a quite a lot of problems provided by this way of making computation, but always we know about this. We can treat this as a design principle. Well, sometimes when the student or engineer, doesn't understand how the computer arithmetics works, can treat this as an error. But in general, these are not errors. These are our decisions. Let's talk about the hardware. Well, in general, computers are so complicated device. When something goes wrong, overheating the processor, some kind of memory errors, or other situation, computers stop working. Of course, sometimes it can happen that accidentally by, well, cosmic rays can flip one bit in a memory, random bit flipping. Well, it's quite rare when you use memory without parity bit collection. This happens once per 7 years. When you use memory with parity correction, ECC, once per 700 years. Well, this changed over time, and today's computers are even better. And this, we can say this never happened in modern computers. Well, okay, during data transmission, errors can occur, but in general, all transmissions protocols have some ways of checking if the data are correct. Parity bit is the simplest thing, which is implemented in general. The modern algorithms used during data transmission allow for correcting 2 or sometimes 3 bits errors and can detect any situation when the change more than 3 bits. But the probability of such situation is quite small. Of course, errors on disk can happen, but once again, errors on disk in the image of an application causes that the application cannot be run. Sometimes error in data can happen, but mostly this data will be not understood by the computer and by the application. It will tell you that something is wrong with the data on a disk. In general, we are using control sums on such things like parity bit or retransmission. When something goes wrong, we will repeat transmission again and again and again. And there's, of course, quite a lot of place for errors which are introduced during the process of producing the chip. And there is well-known history of Intel. The story of Intel microprocessor starts with a family of 8086 processors. In 1978, the first 16-bit microprocessor was introduced. It was 8086 processor. The next generation is 8186, and the third generation was 1828 286 processor. In 1985, they introduced 32-bit processors and they name it 8386, 8486, and the next one should be 8586, but Intel changed the name. From that moment, the processor will have name Pentium or P5. And story described by Thomas Nicely, mathematician who makes some numeric computation, working in the computational number theory, discovered that the new introduced Pentium processor has some strange error. Intel engineers realized in May 1994 that this processor incorrectly computes one division. There is a really big problem with making divisions in computers, because, as you know, and when you try to divide these two values on a paper, it's a really tricky way. You have to try and change decision made by subtracting values. Well, in this value for millions and something, the value 3 millions and something will fit 1. So we write here 1 and next subtract these values and got some reminder and try to guess how many times this will fit in the reminder. So this process in modern microprocessor is replaced by some tables when the division of each combination bit is stored somehow, and some part of this table was corrupted during the production process, and instead of such a result, computer produce such a value. Look, there's not very big difference on the fourth digit after the decimal point should be 8, and here is 7. Nicely performed some tests from July to November 94 and confirmed that the bug is caused not by the software, but by a processor. Sent some information about this to his colleagues. And after some time, all this internet, which was much smaller than today's, start discussing about this problem. So the story first appeared in the press on November the 7th. Well, it's a time when people start to plan some gifts for Christmas. So, you know, on one side you have quite a lot of advertisements telling about the best and fastest and most complicated microprocessor of the market, buy computer with Pentium processor on one hand, and on the other hand, you got this processor has some bugs. Intel well know about this bug. Firstly, they discovered in May, but that doesn't inform society about this situation. So they do produce such a report telling how often this error can cause some problems in your computation, and comparing to other sources of errors caused by a hardware. So PC user on spreadsheet running 1,000 independent devices a day on the Pentium processor has probably will got this error after 27,000 years. So well, probably only scientists making some numerical computation can be harmed by this error. But this is not the first fault of Intel. Going back to the history, first processor with some errors introduced during the production process was 8186. This error was, well, described by Intel, and this processor were used only in some device when they can be programmed in special way to avoid such an error, but never was used in PCs. So PCs there was 8086, and the next one 8286 processor, 16-bit processors. This was never used in PC computers, but there was used in some specialized hardware when specialized software can avoid this bug. The biggest problem with processor introduced error is connected with parallel computation performed on the processors, and each application working inside memory has his own part of a memory available for application. And the application cannot go behind this memory. Processor and operating system stops such an application. But data from this application goes to the microprocessor. And to the microprocessor goes data from this application, for this application, and for this application. Each microprocessor has several cores. And has common memory, cache memory. And data in cache memory are not protected. So this can happen, but you have to write very special software to steal data from one process by another process. These errors are called meltdown and spectre, and practically all microprocessors having more than one core are more or less harmed by these errors. It's a really big problem. It's very difficult to patch, make changes to the software, because the one way to patch is to disallow parallel computation of processors. Processor uses only data from one process and start processing one application, switch to another application. It's a really big problem. But in general, computers do not err. The main source of a problem is the software. Software always has errors. Software producers send us patches to patch the error and install new version. After Windows 10, you have Windows 11, which is much better, eliminates some errors, introducing new ones. And this problem never ends. When you will try to read very carefully the EULA, the end user license agreement, you will find that you are warned that the software will have an errors. The errors are known. The software producer knows that produces software with errors, tells that it will try to remove these errors, but only when this is commercially reasonable. And the warranty is limited to 90 days, for example. And when something happens, you will get money back, but not more than you pay for a software. Think about the Excel, for example, which is very often used in some computations, in accounting, for example, in data processing and in such things, and is used by real firms which earn money using this software. And what happens if the software introduces some errors? It's only your problem, not the software producer. This is really EULA from one of the Microsoft products, and Microsoft is the biggest software company on the market, selling most of the operating softwares, selling you this Office package and other packages. Under any provision of this EULA, entire liability under any provisions of this EULA shall be limited to the greater of the amount actually paid by you for the software product, or $5. This is company liability for errors introduced in software. And according to the recent report, the cost of a poor software quality in the US, the total cost of pure software quality is $2.08 trillion only in the United States. So it's a really big problem. Well, what about software free of errors? TeX is a typesetting system or formatting system which was designed and written by one person, Donald Knuth, and released in 1978. And Knuth periodically tries to remove any errors found in this software. This software is still in use, and to produce these slides, I'm using, well, more or less this software. And look here, this is the plot showing number of errors in TeX. From 1988 to 1998. Well, in the beginning, quite a lot, but the number of errors is smaller and smaller. Why he obtained this? Well, very complicated process, but he decided to pay for each error found by his customers, users of the software, pay 256 US cents. Which was called one hexadecimal dollar. For the first error, accepted by Knut as an error, $1. The second error, $2. There are several categories of each dollar, and you can complain about errors. But well, most people choose not to realize check they got from Knut, but only put it under the glass above his desks to show the others that they are so active users of this beautiful software that they found an error, and this error was accepted by Knut. So there's he hasn't spent much money, but well, produce almost error-free software. The most way of removing errors is testing and debugging and making patches. But you know, how to find the error in software? Well, firstly, you have to, I was talking about algorithm treated as a function. You have to define all legal inputs. The algorithm is treated as some kind of a relationship between the input and the desired output. And what is used in this process is distinguishing between two situations. The first one is that we're starting with data put into the algorithm, and when the algorithm ends, we will got correct sometimes algorithms go into infinite loop and never end his execution. So we doesn't got any result. But when we got some result, the result is correct. This is called partial correctness. And full correctness of algorithm is when we have data, go through an algorithm, algorithms every time ends, and we got good result. These two situations can be distinguished, and in some cases we can prove that algorithm is correct, but it's not very easy. because when the algorithm is correct, we can prove that this algorithm is correct. But when we cannot prove correctness of an algorithm, we don't know if we cannot find proper way of proving the correctness, or if the algorithm is not correct at all. So this is really, this is a partial correction defined here and total correctness defined in here. Every time algorithms end computation and gives us correct result. Proving the correctness is very difficult. And please do remember, if you find one set of data which can be used as a legal data for an algorithm, and the algorithm gives you wrong result, the algorithm is wrong. Well, there is list of software bugs. You can find it on Wikipedia. Some of them are written here. I think that we should go to them and fastly, but look, in the early 1960s, spaceship, the Mariner series, was lost forever due to a mistake in a flight control computer program. The most known probably error was caused by a so-called Millennium Bug. Some fighters going through the date changing and stopped working after, because the date was changed in the wrong way. And the most known situation was software error in Patriot, caused its system clock to drift by 1/3 of a second over a period of 100 hours. 100 hours is about 5 days or something like this. And because these Patriots never work so long, the error was never recognized. But in Israel, they have to work for a very long time, and this caused some very serious error in computation. And cannot locate some missile. And this kills 28 Americans. This was end from me. And now who will present as a first?
So maybe we?
Yes, please try to share your screen.
Okay.
Probably you can.
Is it visible?
It's visible, but well, please try to switch into somehow tricky in Windows and PowerPoint presentation to share the presentation screen, not the editor screen.
Okay.
Maybe click F11.
Well, it's okay now.
Okay, what is Bluetooth? Bluetooth is a wireless technology that uses a radio frequency to share data over a short distance, eliminating the need for wires. You can use Bluetooth on your mobile device to share documents or to connect with other Bluetooth-enabled devices. For security reasons, Bluetooth devices must be paired before they can begin transferring information. And how does Bluetooth work? Bluetooth sends and receives radio waves in a band of 79 different frequencies, channels, centered on 2.45 gigahertz, set apart from radio, television, and cell phones, and reserved for use by industrial, scientific, and medical gadgets. A Bluetooth device works by using radio waves instead of wires or cables to connect with your cell phone, smartphone, or computer. So when Bluetooth-enabled products, such as cell phone and headphones, are in close proximity to each other, they connect or pair. When was the Bluetooth invented? Job Hurston has been active in the area of wireless communications for more than 25 years. In 1994, he laid the foundations for the system that was later known as the Bluetooth wireless technology, enabling connections between a seemingly endless array of devices. Why was Bluetooth invented? It was invented to enable a wide range of devices to work together. And Job Hurston was a Dutch electrical engineer, a researcher, inventor, and entrepreneur, best known for his role in producing the specific role for Bluetooth. How Bluetooth got its name? Surprisingly, the name dates back more than a millennia to King Harald Bluetooth Gormson, who was well known for two things: uniting Denmark and Norway in 958. His dead tooth, which was a dark blue-gray color, earned him the nickname Bluetooth.
Now we will talk about the evolution of Bluetooth. Each generation has got slightly better. In short, the main differences between each generation of Bluetooth standards are in its transfer speed, energy consumption, range, and also safety of this wireless connection. For example, Bluetooth 1.0 is only capable to transfer 21 kilobytes of data. Bluetooth 2.0 is 1,000 times faster than the first approach to Bluetooth, which with speeds reaching 2.1 megabytes per second. Next generation got even faster, with speeds reaching up to 24 megabytes in version 3.0. Nowadays, Bluetooth 5 standard is capable of transferring up to 50 megabytes of data per second. Version 1.0 and 1.0b had many problems, and manufacturers had difficulties making their product interoperable. Version 1.0 and 1.0b also had mandatory Bluetooth hardware device address transmission in the connecting process, rendering anonymity impossible at a protocol level, which was a major setback for services. The most significant change to Bluetooth in version 1.1 involves authentication. Bluetooth communication are encrypted for security. When two Bluetooth devices try to establish a link, one of the first things they do is exchange keys confirming their identities. If the keys don't match, the two devices won't talk to each other. Version 1.2 Version 1.2 is backward compatible with 1.1, and the major enhancements including the following: faster connection and discovery, adaptive frequency hopping spectrum, which improves resistance to radio frequency interference by avoiding the use of crowded frequencies in the hopping sequence, higher transmission speeds in practice. In Bluetooth 2.0, the power consumption was lowered throughout a reduced duty cycle. Multi-link scenarios get simplified due to available bandwidth. Version 2.0 is capable of speeds up to 2.1 megabytes per second. And version 2.1 enables an encryption key to be refreshed, enabling much stronger encryption for connections.
Nie mogę dać dalej. Okay, Bluetooth 3.0 was adopted in 2009. It provides theoretical data transfer speeds up to 24 megabytes per second, permits sending service data without establishing an ecliptic channel, but only for small amounts of data. Updates the power control feature to remove the open loop. Bluetooth 4.0, also known as Bluetooth Low Energy, has been adopted in 2010 and was updated 2013. It includes classic Bluetooth, Bluetooth High Speed, and Bluetooth Low Energy protocols. It is intended to reduce power consumption and cost while maintaining a similar communication range. And new features in Bluetooth 4.1 is mobilized wireless service, low duty circle, dual mode, fast data advertising, and limited discovery time. And released in December 2014, Bluetooth 4.2. And the major improvement were low energy secure connection, link layer privacy, and internet protocol support profile. And released in 2016, Bluetooth 5. Its new features are mainly focused on new internet technology. Sony was the first to announce Bluetooth 5 to simplifying our marketing, communication, users' benefits more efficiently and making it easier. The major improvement are LE long range, high duty circle, and then was released in 2019, the Bluetooth 5.1. And at the end of this year, Bluetooth 5.2, it changed attribute protocol. And then released on July 2021, Bluetooth 5.3. And the main improvements were connection subrating, periodic advertisement, channel classification, and encrypting key size control. And we have a summary video.
We cannot listen. You have to share desktop with sound. It's a special way. So please stop sharing and reshare, checking them on the left, lower left corner. Share with sound.
Okay, maybe now.
Still not.
Now?
No.
Okay, so maybe we can send it.
I will make a print screen and show you that I have re-established the session and try to show you when to. Sorry, this takes quite a lot of time clicking. Yes, this share screen. Look here, there is when you start sharing, there is in the lower left corner, share sound. You have to tick here.
Okay.
I enable sharing screen. Oh, sorry. Yes.
Bluetooth. It cuts the cord and establishes a wireless connection between two devices. Bluetooth transfers data through low-power radio waves whose frequency ranges from 2.40 GHz to 2.485 GHz. Bluetooth devices come in three classes. Class 1 devices are used for industrial applications and have a range of 100 meters. Devices like your mobile phone or Bluetooth headset are Class 2 devices which have a range of 10 meters. Class 3 devices have a range of about 1 meter and are rarely used. With Bluetooth, you can connect 7 devices to one device and form a network of your own called the Piconet. But how is a file transferred from one device to the other one? Bluetooth uses something called the ISM radio frequency band for communicating with other devices. ISM stands for Industrial, Scientific and Medical Devices Band. Every Bluetooth device has a transmitting and a receiving antenna. The file is transferred by the spread spectrum frequency hopping technique. That is, parts of the file are sent by small bursts of radio waves whose frequency can change up to 1600 times per second to avoid interference in crowded environments. The new Bluetooth Smart technology uses as low as 0.01 watts to 0.5 watts. Hence, using Bluetooth does not drain your phone's battery. We are done with the technical aspects of Bluetooth. Now we want to know, why does Bluetooth have this weird name? Now, many people won't believe me on this one, but Bluetooth is called Bluetooth because the scientist who invented it actually had blue teeth. No, I'm just kidding. Bluetooth was developed by the telecommunication company Ericsson in 1994 and was initially called Short Link Radio Technology until 1997 when it got the name Bluetooth. Bluetooth is called Bluetooth because it is named after the Danish king Harald Blaatand. This king had this unique ability to bring quarreling people or tribes with feuds into calmly talking to each other and thus ending the argument. The literal translation of Blaatand is Bluetooth, and Bluetooth does exactly what Blaatand did. It connects two non-connected devices. Even the symbol of Bluetooth has the initials of Harald Blaatand in it. This is the unique H and the B is inscribed inside the H. And that was Bluetooth for you. If you learned something new, then give this video a like and subscribe.
Okay, thank you.
Thank you very much. Do you have any questions? Well, what I can add here is that Bluetooth is sometimes used for connecting so-called smart home devices to computers to measure temperature, for example, or such things. But well, it's not as safe as you are talking. I do remember when during this class years ago, when I'm using my Ericsson phone as a remote for changing slates and communicate with my laptop via Bluetooth, students sent me some funny pictures to my computer, and I cannot avoid this. So it was a really funny situation. Okay, any other questions, comments? If not, may I ask next presenter to start his presentation?
Yes, okay.
Wow. Once again, yes,
Can you see? Yes. Okay.
perfect.
Okay, so I'm going to present to you the subject I decided to work on, which is facial recognition technology in American schools. And I decided to work on this subject because I read an article from the New York Times, which was talking about this project to implement facial recognition technology in schools from a New York district. And it was telling what could be the issues and how is it implemented. So my main concern will be what is the problem with facial recognition technology used in schools? And to answer that question, I'm going to divide the presentation into 2 points. The first one is devoted to what is facial recognition technology and how it works. And the second point will be dedicated to the problems and why are they problems. So the first part, at first, what is it? So it's basically a system that is able to store some information about someone's face and to identify if it's the right person or not. And there is 3 types of facial recognition systems. The traditional one, which is not very advanced because it's basically comparing like a photo straight and to someone who is looking straight to the camera. The 3D one is working quite the same, but it's able to recognize people that are moving from different angle and with different lights too. So it's a bit more advanced and accurate. And the biometric one is adding a biometric parameter. So it can be the face shape or the skin texture. And it's the more advanced because it's even able to make difference between 2 identical twins. What is interesting also with this technology is it's finally something we all know because of smartphones, for example, because in Apple phones, the most recent one has Face ID, and it's a facial recognition system. It's a 3D one. So it's something that is really common nowadays. Even in FBI, for example, they have database face recognition, and it's always growing. So it means that they are able to identify more and more people. So it's a bit of a context to this subject. And how is it used in American schools? So here is a quotation from the article. It helps security staff identify individuals who may pose threats to students and staff members and to detect weapons. So what we can understand from this, it's that the main goal is to enforce security. So as you may know, in America, they are really often facing security problems in schools with shooting rampage. So this is something that is really a trauma for them, and we understand they need to do something to avoid that kind of problems. And what we can say about that is that it's also probably a 3D facial recognition technology, because according to the article, it seems that it's a lot of cameras that are installed in the schools. So they are able to recognize people that are moving and not only people in front of a camera. And it doesn't add neither biometric parameters. So we can move on the second part, what can be the problems and why? And the first one we can think about is privacy concerns, because we all deal with that kind of problems nowadays with cookies and so on when we surf on the internet. And in general, we can answer the 3 questions here. Where is it stored, for how long, and who can access this? We can find the information on the websites in general. But here, what we can say from the article and from research on the internet is that it's not really clear, because nobody agree with what they should do with this system. What information do they have to store, for how long, and nobody agree with this. So it leads to the second problem, the misuse of facial recognition. For some people, and mainly parents, it's a way to treat children as criminals. And someone even say it's considering that students are lab rats, because of course it's not implemented in all American schools. It's implemented only in a district of New York. So it's like an experimentation, and some things doesn't work, but it's currently installed. So for some people, it's a problem. What we can say also is that students are not well aware of the use because of the way they answer to the interviewer. Some of them didn't even know where was the cameras, and the other were saying that they were not fully informed about the use, how was it done, and so on. Also, something we can underline is that the policies have been decided between adults, which is normal for some schools because it's for 5 years old children, so they don't have an opinion on privacy content. But for teenagers, for example, they are able to understand at least, but they are not aware of the use of their private data, sorry. And we can add also that there is a possibility of human error, because right now, if the system is identifying a threat, it asks a human monitor to look at the picture and to say if it's really a threat or not. And in general, people are all agree to give a lot of power to human, but in general, human mistakes are more numerous than computer one. And the last problem we can underline, which was quite strange at the first time, is discriminations, because facial recognition is very accurate at identifying white men, but less so for women or people of color. And it has a simple explanation. It's because this system was invented by white men and calibrated mainly on white men. And as for a lot of technology stuff, they need to be trained to be more accurate. And above the discrimination problem, which we know is a problem in United States with, for example, Black Lives Matter movement, it's also something that is a problem for the system, because if there is too many mistakes, at the end, people won't rely on the system. And when there will be a real threat, nobody will be as reactive as they need to. So in conclusion, we can understand easily that American people need to enforce security with all things they know. It's also a way to avoid sexual predators and people that were not allowed to enter schools. But what we need to remember is that for shooting rampage, it's mainly from teenagers from the school that it occurs. And right now, the school doesn't allow to identify students in the system, because of privacy problems. So maybe this system needs to be more trained, and the boundaries need to be fixed before being completely efficient. So that was the end of my presentation. Thank you for your attention. And here are the sources.
Thank you very much. Waiting for any questions, comments. Dear all, please. Well, if there are no comments, I would like to add one. There is a really big problem with so-called artificial intelligence, that it's very often, and this has special name, the results of recognition of artificial intelligence are biased. This means that on depend on training data which were used for train the artificial intelligence in every situation. Once, when the American airports want to try such a system in airports where the traffic people movement is very high, they recognize that there is so many false positives. This means that artificial intelligence, face recognition system detects some kind of a criminals, which are not, in fact, criminals, that this will stop the work of and block absolutely the airport. So they resign for this. On the other hand, probably most of a modern mobile phone use face recognition technology to unlock the device, which is somehow, well, who has our face data? Phone producer, Google. Do you think about this? The same with unlocking a phone using your finger. How efficient is this? There's quite a lot of questions arise when using this high technology. So still 10 minutes. Do you have any comments, any questions? Maybe with further presentations? Cannot see. If not, can we end the class? If so, thank you very much. See you again next week. And please be prepared for everything which can happen, especially with PowerPoint presentation. There is information on my web page taken from the
You are muted, sir.
Sorry, my Zoom is stopped working every time I try to do something. There is a link on my web page how to use PowerPoint, and I will try to find this and during screen sharing, and is unfortunately it's in Polish for our students, and oh, sorry, then this article isn't available. I will try to find it on a Zoom page, and oh yes, works. Screen sharing a PowerPoint presentation. These are some remarks. I will try to send you this in a chat window. To be prepared. Any other questions, comments? If no, thank you very much. Bye. See you next week.
Thank you. Bye.